All right, we have a YiXiang DIY battery box. It's for a 51.2 volt battery build that you supply your own batteries with. And the YiXiang people, they were kind enough to send us the box without any batteries. So we're going to go over the build quality. We have some of our own cells that we're going to put in there so we can at least fire it up and see what it looks like. We're going to show it. This is the first time we haven't even looked in to see what comes with it. So we'll know that shortly. But the overall view of it, it's a stackable, it's a server rack style, and you can stack, I'm not sure how many, but they have little feet on the bottom. I'll just show you some little quick features on here just real quick. So you got little feet down here. And so it's sitting up just a little bit off of the tabletop. And there's corresponding holes, pretty heavy, corresponding holes here on the top. And so if you're going to stack this thing, you can actually stack and the feet on the bottom will fit into these holes. And you also got some latches. If you want to put more than one, you can latch it down because the next one's going to have this latch here so you can secure them. We only have one, so we're not going to be messing with any of that. Yeah, hand holds on the side, not much to it. It does take a couple of people to lift this thing. Empty, you can lift it yourself, but when you put cells in there, ain't no way you're going to be doing it by yourself. It is basically, it'll hold 280 amp hour to 320 amp hour cells according to the specs on it. It has a JK BMS. Not totally positive what we're looking at on that. There's nothing on the literature that we got. This is the instruction manual. I'll show you what we got here for the build. When you start putting it together, it looks like this. Not a lot of info, except some of the basics on how to put it together. And I'm pretty sure we'll be able to figure it out. Because other people have done it, hopefully we can do it. So this, what you're looking at on the front is just your positive and negative terminals. You've got a big old circuit breaker, 200 amp circuit breaker. This is where the display is going to go, and we're guessing the display's in here. And then everything's just standard. You have all your connections up front, any kind of warning lights or state of charge lights. Now, we have not opened this. I've taken all the screws out except one, and we're going to do a dramatic lifting the top off and see what in the world we have. Because we're highly curious if there's any bus bars with it. This is just our own curiosity because we're supplying our own cells, and it looks like everybody has getting the battery cells with the two holes on the terminal. We don't have anything like that. So, okay, dramatically, we're going to take the top off and set it aside. There's no, the top is just kind of powder coated like the rest of the box there. Let's see what we got in here. Okay, we've got the PCB rails. I'm going to whip those out real quick because we need to get down to the contents in here. Okay, all the screws are out. Let's take a look at how it's put together first so we'll know when we put it back together what we're looking at. So we've got definite size. We've got a part B and a part A. And so on your positive terminal is going to be over here. I know that. And your negative terminal is going to be over here. So the B is for the positive terminal, which makes sense because you have the red wire. But look at the instruction and make sure you do everything right. You just want to put these back the way they're supposed to go. All right, well, let's take a look at this real quick first. It is, it's just carrying, instead of having a lot of wires in here, this is kind of common on these factory built type batteries or DIY boxes. You have this PCB, this board in here that carries all of your battery or voltage sense leads. And I'm going to take a guess that some of these, that's going to be go to your negative terminal because this is the negative side. These look like temperature sense leads, and it's all built in for you. So we're going to set those aside. There, again, they're just all kind of powder coated. And I'm guessing there's something to put on the bottom of those. I see it already. Got a package. We'll take it apart in a minute, but it looks like it's got foam spacers. I think it's the EVA type foam. And this has a little paper that should pull off to adhere onto your individual battery cells for spacing. And I see some separator material, fiberglass or whatever they call this stuff in here, but it doesn't look like it's for every battery cell. So we're counting on this foam to keep maintain separation between the cells. These we'll get into. These would look like for the bottoms, to line the bottoms and the sides for each one. And let's go to 4. Okay. There's some liners. These are your tops and sides. These, okay, that's nice. These will go to these PCB bars. We're not gonna put it on right now, but this is how it works. You can see the holes line up there, so we'll pull the paper off and then adhere it down, and that'll sit on top of that'll sit on top of the individual battery cells. See what else we got. Okay, we'll look in the big box first. All right. Oh, we have some of our favorite bus bar covers, the little plastic clear things that are really hard to get on and off. We got some hardware. Okay, this is going to be interesting because we don't have these batteries. So this is for the double terminal, or the batteries with the terminal that have 2 holes in them. And the bus bars are going to be the same. So they're nice, flexible looking copper bus bars. Really like the bus bars. I just don't know how this is going to work for our application because our batteries are just standard EV cells. Okay, you got some magnetic screens. This looks like maybe insects. Keep insects from crawling in and out of there. Definitely not going to do anything for dust or anything, so that's probably what that is. Keep bugs from going in and out of your deal there. Look at this, a fire extinguisher. That'll be interesting. Everything else is pretty standard looking. You got a communication cable. And these, it looks like everything's already here for your voltage sense lead, so I'm not really sure what this would be, but there are 4 in here, and I guess if you wanted to make your own sense leads, you didn't want to use the rail here, the PCB type rail, or you didn't want to hook up to it, you can customize and make your own battery sense leads or voltage sense leads, and zip ties. Guessing the zip ties are for just tidying some stuff up in there. See what's in box number 2. The mystery box contains, the display. Get that out of there. Okay, we'll take that out when we get to it, but that's the display that'll go in here eventually. It looks like it's already assembled. Like everything's put together here. This is going to be your negative side, your negative, the final negative, or most negative as they might call it, and your most positive or positive connection here. Everything is put together. That's pretty nice. So it's a DIY, but they've DIY'd it to really putting it together for you. And if we see in there, it looks like, I can't really tell what BMS that is, but they keep advertising that it's the JK 200 amp, and they call it the version 19, which seems to be a fairly common version. I think that's just the firmware version for the BMS, but yeah, your basic JK BMS. So when we get into it, we're going to have to pull up the BMS app, or the JK BMS app, to really get a good look at this stuff, because we'll get some information on the display. We'll find that out later. So we're going to lay it back down and see how we get the cells in there. Going to go to the next steps that we see looks to be what's most logical. We put the fire extinguishing unit in here because we're looking like, well, the batteries are going to be up in the way, kind of up in your, like up for your areas. It's just 2 screws. They go right in here, 2 nuts. You put it on, and then we just like the cable. This will end up snaking around in here on top of the PCBs. So we're just going to put it out of the way, and we'll deal with that later. To get the batteries in, we were debating on whether just to drop them in, but we really don't want to hold them from the terminals and be pulling them in and out with the terminals. So we're going to go ahead and pull the front down, and there's a plate in here that's kind of a fixture plate. It's not really going to do compression from what I can tell, but we're going to pull that plate back. And before we do that, we're going to do real quickly, just show you what in the world's going on here. You've got all these big yellow boards, and they look like they're just isolating, I don't know, they look like fiberglass boards. So they're pretty much just going to isolate your batteries from the metal box. We are always hoping that these are non-conductive boxes on here. And these, if you look, those had no tape on them. These have some tape, and it looks like the purpose of the tape is going to be so you can take the tape or pull the little pieces off, and then when you put them up, they'll adhere. So yeah, you'll have these. We should have 3 more. Yep. So when we pull the tape pieces off, protectors off, they'll go in just like this, and then they'll actually stick on there. So we'll get to that in a minute. These parts right here, we're probably going to have one for each end as well. So we'll drop that in. Now there's no tape for those. The batteries are going to hold it up. So what we're going to do now is just pull the front off before we really get into this very much. I took all the screws out except for one, so you don't have to watch the agonizing unboxing. We installed the fiberglass separator plates in here just to get all that out of the way, so we have them in the bottoms. You take the tape off, and yeah, they kind of adhere up in here. And we could save everybody on YouTube that watches this video probably a cumulative of many hours. The tape in the middle doesn't line up with the middle bar, and I spent a couple minutes trying to figure out how do you flip it to make it, because the tape is offset. Anyway, just pull the tape off and put them in there. Don't worry about the middle alignment of this little piece of clear double-sided tape in there. Okay, we're going to pull this off, and I've taken all the screws out. You just take all the perimeter screws off here. We wanted to leave the last one in so you can see what we're doing here. This is kind of like unboxing without the drama. Okay, we're going to pull the one screw and see what we got here. All right, what do we have here? Okay, it looks like we have everything connected already. Now, a guy could go through and check all these connections. You could probably go through and torque them and make sure they're all tight. Now, see, now that was loose. Just look at that. I was able to snug it down. So that's going to make me think we should go through when this is kind of pulled apart a little bit and make sure this stuff's good. So what we want to get to is our goal here is to be able to pull this plate back a little bit so we can get our cells in a lot easier. That's going to be a little more harder said than done unless we can figure out how to get these.
Slide that off to the side, to the left, and then do the other side.
Good idea. See if we can do that. Okay, we're just using a number 3 screwdriver here. Okay, I feel like this is an optional play. You may or may not have to do that. You may or may not want to do it. It's 6 screws, 2 on either side, and then 2 down the middle. You do have to have the front taken off, and you would want to remove at least your cable off of the negative side right here, so you can slip the stuff out of the way. Then you can get here and look at your BMS. We want to check the tightness on these as well. So you've got these. You got some screws here you want to check while the front's down, because we did find this one a little bit loose, and so we're going to go through and check them after we get the battery cells in before we reassemble everything. You got a good shot of your BMS right here, and I suppose that with that QR code, maybe you can scan it and download the app to a phone. Don't know what that's for. We'll find out. And you can also get in here and make sure everything's tight. So double check it. Next thing we're going to do is move to just like loading the cells in here and get that out of the way. So that's what we're going to get next. All right, so as we discussed before, we mentioned before, the cells that these are designed to work with the bus bars that come with it are the kind that have the 2 holes, and that's not what we have. And they use even screws. We have bolts that fit on ours. And we may get some in the future, but what we have available to us right now are just these standard EVE type battery cells, or cells that are the single post terminal. So it's going to be a little peculiar how we have to do this. Now we did look at it, and we can use these bus bars, and we'll show you how. If it doesn't really work out, we do have some bus bars that we can put with this. Now, because of that, normally what you would do is you would take your battery cell and pull the paper off, and then you would adhere it to one side of all these batteries going down so that each one has a space in between. We're going to do it a little bit different because we may pull these apart and put the double stud, whatever you call it, bus or battery individual cells in here. So we're just going to like place them in and then drop these in between so we can disassemble it and use these when we have correct cells. Now, the way this is oriented, your most positive terminal is up on the very front. Your most negative is on this side right here. So we're going to start from the back because we know if we put, and this is just a matter of putting them together, you just orient them how you need to. Negative is going to be back here. Let's take that back. We've got to have a, where did that go? Okay. So be sure to put your, that there. I'll put you up there, and we're going to take it, we'll check it when we get to the end, but it's possible that a piece of foam goes down in here as well, but we'll deal with that when we get there. So we're going to alternate. We're going negative, and that's positive. So our next one, we just load it up this way. Series connection, positive to negative. Put those in. So when we're making our bridge, negative, positive. Front, we get a piece and a piece. Okay, before we put all the screws in, we'll just reinstall all the screws. We're going to double check in here, make sure we don't have anything messed up, or we have to pull the front off again. This, these connections are for the balance. They'll plug into the PCBs up here, and they're color coded, if I remember right. So they are A is white, so you want to make sure this one's free enough to make it over to here. And the black one is B, which would be the positive side, so that's good. So we're just going to look through here, make sure it's all good, double check all your wires, nothing's binding. Display cord, you got that running out the front, and yeah, there's your positive, and this is a positive lead that's going to go on there. That fires the BMS up. This is actually the BMS power for the positive, but that comes later on in the game. All right, so there we have this. The next thing to do would be to, we can connect the bus bars and start doing our bus bar connection. One thing we want to do before we get to that is we do want to put this foam onto these. I think that's the same. Okay, now for the bus bars, we're going to take a look at these since our bus bars are just a wee bit different. Got my glasses on here. And we would leave, this is the positive, so that's going to hook to the bus bar. And we double check, I mean, if you built one of these things before you have any idea how these things work, you should probably, that's probably why you're watching this. If you don't, you just have to be real careful. Make sure everything's alternating. Series connections is always a plus, minus, positive, negative, positive, negative, positive, negative. Make sure you got that alternation. And then we're going to bridge this at a later time. We're going to go from negative here to this positive. So then we should have the same thing going forward. Negative, positive, negative, positive, negative, positive, negative, positive, and the final negative. So we can start laying the bus bars on. And out of curiosity, we did try these, and they will work. We can use them. It's a little bit awkward right there, but we're going to give it a shot. So we go negative, positive. It should be negative to positive here, right? You saw me tap that and pull it off. We should have roughly, what, 25 volts here, 26.71, that's perfect. We go to the other side, 26.71. Okay, so we know we're good to that point. Looks like the next thing we want to do is, before we start putting bolts on, we would normally start putting, we'd put our bolts on here, but we need to lay these PCBs on. And because the way they work is we have to put these with the onto the positives. So like this is going to be a positive, this is going to be a positive. You can see how that works. This is the voltage sense leads. And it's also where any balancing is going to happen. It's going to run through these particular wires right here to do your balancing that the BMS is going to provide. And this is where it's kind of detrimental for us. We're just going to have to kind of work with it a little bit. I think it'll be fine. But the temperature sense leads, we would go to a negative. So we'd find a close negative. So we'd go with this negative. And there's another temperature back here. It'll go to that negative. And with this, we're going to kind of mess with it a little bit. I want to make sure it's going to work right. But yeah, if we set it down on here, and again, we want to make sure we got the right one. B is over here, and your black connector is that's where it goes to your BMS for your voltage sensing and balancing. All right, so the next task we have the rails, we have everything installed, put together. We have yet to put the voltage sense leads on the positives. And each of these, it's kind of nice if you can look in here real quick, you see on the PCB, this rail running down, it's got the numbers, it's kind of nice. B1 positive, B1 minus, there's your B2, battery cell 2 positive. Battery cell 3, and it goes all the way over here. This is number 16 positive. So we have to put all the red wires, makes it nice. The red wires all go under the, we put them on like this on each positive, because that's how BMSs work. So we have to go through and do every one of those. And if you're kind of curious about what all this stuff is on the nuts we're using, well, it's from another project that we had to take, and it's just some kind of silicone goop stuff that was put on to keep them from moving, but we got to use them. So all we're going to do is kind of come through and snug these down, these sense lead ring terminals. I did go through already and kind of check them out. If you look at them, I'll show you one here in just a minute. And we're not going to torque it, we're just kind of tightening it. Double check, and I had to cut one of these back, but you know, when we make our own, we're very careful. We don't put the insulation up that far. It's not necessary. But these, they, you know, well, I don't know, they kind of put the insulation up really close to the ring. And it just kind of makes for kind of a wonky insulation when you put a bolt on top of it. It's just not going to seat as well as you might want it. And I did have to cut one back. This one right here. This is the positive. This goes to the positive to energize the BMS. We're not going to put it on yet. But this one was like way up in here. And you can see it's kind of got some solder. So I kind of scratched on the solder. And the hope was, is when we put the nut on, it's not going to sit, you know, all crooked and sideways. So that's going to look okay. Otherwise, before I cut it, this black was encroaching up in there. Anyway, that's just something to kind of look out for. Now, I got to go through and put nuts on all of these. Now, there is one thing. These are the, I'll show you real quick. This is the temperature sense leads. And these go to the negative. So we're going to find some negatives to put them on. And well, see, we'll put it on this one or this one. When you come back, you'll see which one it is, probably this one. So yeah, all that does, it goes underneath here. And there's two on each side. So we'll put this one in as well, maybe down here. And then we have two over here, same thing. And once we get all these things down, you know what? Do you think we should run the extinguisher thing first? This is the cable for the fire extinguishing little device. Let's take a look, because I don't think the directions really tell you a whole lot about it. The way I'm seeing it, it's going to run on top of these. I guess you could run it inside or on the outside of this rail, but we're going to just put it on the inside. There's going to be a lot of zip ties to fit on here. We may or may not show all that, but the way this thing runs is it's going to snake around here. And we'll probably just run it to maybe across here, because it's kind of long and we want it to terminate before it like runs off the cells. So we're going to terminate it up in here. But yeah, we'll put all those down after, we'll put this down after the fact, I guess. So let's get working on these things here. All right, we went through and tightened everything down. We've got all the positives put under the, we got the positive volt sense leads on. You torque them down. Be sure to check your battery, because the different batteries have different specs. I think these would be like 6 Newton meters, but I'm not positive. I have to look back at the directions. So whatever cell you put in, make sure you find the torque specs so you can go through and torque all of the bolts or screws. In the case of if this was a double terminal, they have screws you torque in. We've gone through and checked everything out and also verified. I went through and counted, you know, like we have I was saying before, B16. We got the battery 16. I went through to make sure that we were, you know, it's hard to mess it up, and make sure the corresponding voltage sense lead was on the correct battery. I'm still looking at them. And all right, so the next thing we do, we'll do this at the very end. This is where we're gonna have to put a bus bar on, but we'll get to that in a minute. First, we're gonna come up here. Oh, we show you the fire extinguisher, forgot about that. We did that while you were out. The way the fire extinguisher runs, it just shows you in the book, the little pamphlet manual. You basically just run it down this side and come over here and run it up to here. Now, they have these, and we're not going to put them in just yet. We'll do it before we close everything up. Just want to make sure it's in the correct place. They give you a bunch of these little zip ties, and the zip ties, we installed one here, but they go in these little slots. You can see a bunch of little slots there, so you just go in there. You got them all over. They've got them in different places. That's what that's for. Now, coming up to the front, we have the breakers off. We've got made sure that was off, and we're going to start connecting the bus bars. Then we'll get to the balance leads or the sense leads. And anyway, let's give it a shot here. So right now, the way it's set up, these are not connected, so should be good. Now, the one thing that you got to remember when you hook this number 16 on, grab this red lead. This goes to the BMS, and it powers the BMS up, so it needs to be installed at the same time. Okay, very nice. Go ahead and tighten it down. Come back to, we'll do torque checks on that one.
Then you had that thing.
So I was touching?
Yes.
You know, thank you for pointing that out. You should never practice touching it even though it's not conductive.
Oh, we don't call you a Sparky for nothing.
Yeah. Yep. You guys have not seen the sparks. Okay, here we go. Negative. We want the negative to go on. This is the most negative or total negative, whatever they call it. And this is the sense lead, part of the voltage sense lead system and balancing. Sometimes these gloves seem to be more dangerous than they're worth, but okay. I'll do it right this time. These are nylocks, that's why I'm having to tighten them with the ratchet, because I didn't want y'all to think I was that weak. Okay, we'll come back and torque that. So we're set up. We're here, we've got everything set up. We have all of these put in, we're just double checking. Then we can go to the sense lead connections. It's pretty easy. This is the A rail, this is the B rail. A rail's on the negative side, B rail's on the positive side. And you typically are going to start with your lower numbers when you hook these things up. So let's get them flipped around like they should be. So this is the number 1 battery. We're going to hook up number 1. This is 1 through 8. They don't give you a whole lot, but it's color coded, so that's pretty cool. It's white. There's little groove slots down here, little groove slots and little groove slots there. So it's how you know you don't have the thing upside down. Plus, I think it would be hard to get upside down, so we're going to plug it in and hope everything goes well. Okay. Oh, kind of lift it up there. Be careful. Okay, we'll come over to this other side. Same thing. We'll double check it. Slots on the back, so we're definitely going in this way. That's it for that. Okay. Now for the final part, for the connection back here in the back, this bus bar that came with it, of course, it's not going to work for us. It's again, we said it's made for the terminals that have the double screws in it, and that's just not going to work. So we're taking one of our aluminum bus bars, and we have to set it on there. Okay, now this is battery number 9, or cell number 9, so we take cell number 9, and we put this negative under it, this negative lead, under here. And this is the positive voltage sense lead for battery number 8. Positive, this is the positive under there, because that's a negative over there. Just double checking, always double checking. When we get this done, we're going to go up here to the top and verify. Again, we would be using the torque wrench on these before we do anything. But we're going to take our multimeter, come up here to the front, and verify. We have 50-something volts. And a lot of people, if you're not familiar with how voltmeters work, I've seen people do this differently. The red is for positive, the black is for negative. If you swap them around, it doesn't matter. However, you'll get a negative up here. I don't think it really hurts anything, but if you do it right the first time, you won't worry about it. Look at that, 53. Let's get this up here where you can see it. These batteries have a little juice in them, 53.4-ish. So we're good. That's what we're looking for. So this thing should be pretty much ready to roll. Now, before we turn things on, we do have to, we do have one other thing to work with, the display. This is something we've not really worked with before, but the display is this right here. And when you're making all this happen, make sure that you have snaked this cable out. If you take it down like we did, which is optional, we remind you, it seems like you can drop them in without having to pull it down, but be sure you have this out. Okay, your display. Now, I'm not really sure, it doesn't say this side up anywhere, so we'll just hook it up and we'll plug it up and see kind of what happens. There's only one thing we can find, it's this one right here, and the only plug it's going to correspond to is this one, so we're just going to snap it in there. Okay, yeah, it won't go in anything else. I think we'll lean it up here and then make sure we got it right side up before we take it off, because it's an adhesive. This is like a little adhesive back here, so when you stick it in, it's going to be in there. Well, let's see, what do you think?
What else is there? You get everything?
I think so. These are cold because this is off, but we can power up the BMS.
Turn that BMS
You ready?
on. Yeah. Oh,
Well, it worked.
it works.
It's amazing, people. Hey, her. Okay, look at that. It's right side up. So should we stick it in there and just
Stick that thing in there.
glue it in? Let's glue it in. Okay, I think this must come off here. Looks good. Let's make sure it's not upside down. Fancy. You know what? After all that, I got it crooked. There is an indentation. Y'all be aware of that. See, there's an inset.
Just leave it, man. Just leave it. It's
Okay,
man. Just
okay.
leave it.
Okay,
It's all right,
that's
it's
what
all
it
right.
is. But for the people out there, when you put it in, don't do what I did. Set it on the bottom and make sure it's in between the little lines there and then rock it in there.
man.
You see it?
The Pinterest police is going to come get us.
Man, we try so hard and we still mess up. Okay, so what do we got here? Let's grab the multimeter and double check and make sure these are indeed not active. Couple little millivolts running around there, which is being normal. Now if we flip it on, oh, there we go, that's a big flipper. Let's check it out real quick. Look at that, 53.4. We've got voltage. Let's make sure they're all got voltage there. Make sure nothing's off. All got voltage. Now, out of safety, we're going to shut you back down. And got your little covers. These are the hardest covers. We just don't like. I just don't like you put your cable in there and then it's hard to get out. We've gone over that with another video. All right, so what we're looking at here is you're getting some basic information. Xing Zhao, here we go to English. Now we can read it. So should have no current going in or out because we have nothing hooked up to it. Capacity is not going to be anywhere close to accurate, but we do have the cell voltage right now, 3.330 in the min. That's pretty nice. It shows you the max in the min. And yeah, temperatures, just some basic information. An alarm. Okay, look at that, pack one. So we must be able to set up different ones if we have some in parallel, which we're going to eventually do, but not with this one. So let's see, oh, touch screen, one pack. There's some settings. We've got some, okay, just some protocols and nothing we're going to be using. But we're getting this alarm right here. And from what it seems like is you have to do something like reset the password and clear something out. So we're going to kind of mess through that, but we have to get the phone app on it. Yeah, we have the alarm here. State of charge is running on. Y'all know what all this stuff is. You got some dip switches. I think if you're going to be putting it in parallel, you have to probably mess with these dip switches, but right now they're all in the up position. You know, your contacts and all your RS-45s, CAN buses and all that. If you're going to be running some closed loop communication, which, like I said, hopefully in the future we will have a few that we can run some closed loop on and see how the packs talk to each other when we have several that have the same BMS in there, the JK. Now let's pull the app out. All right, so we got the app on. We went to the Google Play Store to get the app. It was just the JK BMS, and I think there's different ways to get it, but for the Android, that seemed to be the easiest. And it just installs, and you do have to go through a couple of things when you do the startup. You have to pair it, and the pairing, there's a number for pairing, and it's 1, 2, 3, 4, and that'll get it to pair to the app, your phone, to the BMS through Bluetooth. Make sure your Bluetooth is on, and I believe your location has to be turned on as well. And for the alarm that was showing, I'm not really sure what we did. I went through and I changed the time. Let's see if we can find the time here. Went to different settings. We're definitely not JK people, so you can find way better information probably somewhere else. But let's verify the password and see if we can get down here. Yeah, I had to go down here, and the time was off. It was showing like 2020 and another date, so just touch that and it's synced up to the current time. And you can have all these, yeah, I mean, you can just thumb through there and see what you got. But yeah, this thing's kind of like the screen swipe right here to go through and look at all your parameters. And do be sure to set it to Lifep04 up here in the top. I think it was defaulted to the lithium ion. And if we go back to our main screen, this is what we're most interested in. It shows your cell voltage and a lot of the parameters on here. And that's something you just have to kind of play with. So it does work. It was a little bit problematic to get it to pair up because we had all different kind of numbers to put in there, but basic 1, 2, 3, 4 worked. And then you have to reset the internal password. I think that is, if you want to change parameters, that's a different password, and you have to go through reset it. And that one is 1, 2, 3, 4, 5, 6, and then you put a new password in. So it's good for you to put another password in. That's if you want to adjust some of the parameters inside here, you'll need that password. And that looks like it's it for the app. We're going to go back to the screen here and show you a couple of things on the screen. All right, one thing we wanted to show you on the front screen that we've come across after we had stopped recording a minute ago when we went to the app, we were looking for the cell voltages, and it's under packs, and you have to tap on this, and that's where you get all your good information you're going to be looking for. So you can see all of your cell voltages on here. And the number back and forth, it looks like the red and the blue is going to be your high and low. We're not sure what it looks like when the thing is balancing. That's yet to be seen what the screen looks like at that point. But anyway, that's all we wanted to show you on that one is you have to exit out up there. This is the first JK BMS we've ever had. This is the first BMS with an active balancer we've ever had, and we want to see it work. The problem with these cells that we put in is they were somewhat balanced, and we don't have a really big power supply at this location to do our 52, our higher voltage. So we had to create a fake imbalance on this thing. It's real, but we had to use our ZKE tech, which these things are great if you don't have one and if you're doing any kind of battery building or work, or you really want to get your hands dirty. This is kind of a favorite. We like the bench tops. We use these a lot just for all kind of odd stuff. But this thing does 40 amps. Anyway, whole video on that. So what we did is we made a man-made imbalance here on cell number 6. And we just ran it up to 3.6 volts until it kind of saturated. Because what we want to do now is we're going to take the little power supply, the biggest one we have down here that'll do over 50 volts, and we're going to hook it up here, turn everything on, put a little bit of a charge to it, and see if we can see the JK BMS with the active balancer doing its thing. Like I say, this is first for us. So that's why we made a cell imbalance. Okay, when you're using one of these power supplies or any kind of external charger, if you don't have the circuit breaker on, you won't get any charge into the batteries. It'll just sit there dead. So we're going to turn it on. And then we'll come over here and turn our little power supply on. It's only like a 5 amp charger, but hopefully now we can start seeing some kind of imbalancing going on. I think it's going to take a few minutes to get it up. Yeah, because number 6, the one we were working on, is only 3.38. All right, so the BMS, we're going to show you, we have the screen up here. This is the main screen on the box, and this is the JK BMS app, and this is for an Android. I think the iOS systems look the same for Apple's. And what we're looking at, we're not familiar with this too much, but you have a lot of information here on your side, but the thing that we're basically looking at is we have cell voltage differential. We've got a 74 millivolt differential. Oh, and we just, right here, this was, you can see it kind of flash coming in and out. It hit 3.45, and that's where we have our parameter set to start balancing. And before it was just a steady blue, and now you can see it is actually working. And up here at the top, it actually says, you can see the balance on and off. And because it's not really solid above 3.45, like a little bit of whatever it's doing, it's pulling it down enough to where it's just going like toggling right there at 3.45, and you can see the 0.449. The interesting thing, I don't know where it's putting it. You would think it'd be putting it into the red cell, like here, number 4. So the interesting thing would be to kind of watch it and see which one starts going up, and it's going to move around. Like I say, we've never had active balancing, so this is pretty exciting, but this is what it looks like. It actually works, and for that, we are pretty excited that it's actually doing something. And if we go over to we'll flip over to the settings, and some of the things we come across here that was kind of cool is like, okay, the balance trigger voltage, that's like 10 millivolts. That's good. We don't want it to be too high. And it also has the start balance right here, and 3.45 always seems to be the common start point. The max balance current is set at 2 amps because this is a 200 amp BMS with a 2 amp active balancer. And then all the other parameters are just your typical parameters that you can scroll through if you want to look at them. And you see your cell overvolt protect voltage and the release voltages and your under voltage protect. This one was set at 2.9, and well, I'll take that back. The release is at 2.9, so when it gets to 2.5, it'll do a shutdown, and it doesn't release and start discharging again until the lowest cell volt floats up to 2.9 volts. Anyway, this is all pretty common stuff, and you'll have that kind of figured out as you're using this thing. But this is what we're interested in seeing right here. We want to see this balancing, what it did, and we're going to let it run. We've got right now, it's a 77 millivolt differential.
All right, the YiXiang box, we got it put together and it works. And since they didn't send us the batteries, this is just our opinion of the box itself. The components looked good, the bus bars looked good. They included the bus bars for the wrong, or I shouldn't say for the wrong batteries, but we had the wrong cells, but we overcame that. So something to think about if you're supplying your own cells. Now, if you want this box with the cells in it, well, we don't know if their battery cells are any good or not, so we can't endorse that. The box itself, though, is good. I guess a separate video would be DIY versus pre-built, because that is we could kind of talk about the form factor of this box, good or bad, but that's not really the point of this video. The point of the video is, does this box perform? And it did so far. The BMS active balancer was working. Not really any complaints. Did you see anything that you didn't like?
Not really, other than it's heavy, but that's going to be the same thing with any of them. And, you pointed out the difference in a box like this and one that's already got the cells in it.
Yep.
And if we get this thing, and we do have some pre-builts that we've done some videos on, and they are heavy, but they're on wheels, and we can roll them around. And this thing has the side handles. You can see those things.
It's so heavy, like we were trying to move it. We can't, we're going to have a hard time moving it with both of us. So this would be a scenario where you would want to build it in place for sure.
Yeah.
Unless you got two really strong people. And I don't know, we're not weak or anything, but that's pretty heavy.
It's
so
real heavy.
In the wheel thing, that is a good point, because I think they sell the wheel kit, or you could probably even make your own if you wanted to.
Yep.
That I would say is a must have. If you're going to be doing them in this horizontal position like this, you can flip them up and have them up, upright, and that would be good too. But then you have to think about how you're going to move them if you need to. So the wheel option is a really good thing, I think, because if you got to move them any amount of distance in your house or your garage, having them on wheels is going to be a really nice back saver.
Yeah. And it'd be nice. You can put them on the wheel, dolly or trolley, or make your own little thing, and then build one, and then close it up, and then you can, test it, and then build the other one and set right down on top of it. That'd be pretty handy if you wanted like 2 or 3 of them.
Right. Yeah. Because if you wanted multiples, having them sitting upright, you're not going to be able to. Yeah, you can latch them together and all that stuff, but then you can't move them. Whereas if you leave them like this, you could have multiples on there and still wheel them around. I'm sure it's going to be really heavy, but if you're on a concrete floor, it would be no problem.
Mm-hmm. Are there any drawbacks to that? The only drawback, the one good thing is when you stack them, you got really good density. You have a lot of kilowatt hour density built in here. Storage, but then if you have a problem with one on the bottom,
here you gotta have that strong guy come back, because you're not going to be disassembling them. You don't have to disassemble them just to take them off.
Mm-hmm. Yeah.
Pros and cons. Yeah, if you're running just one of these upright, it's going to be a low footprint. Our Orion Powers that I'm running in my house, they're not that much smaller than this.
Right.
They're thinner. Yeah, they are thinner, but the size is about the same. So this is really compact for how many amp hours you're getting.
Mm-hmm. Yeah, I don't have any problem. I think they're kind of a cool thing if you can figure out how to overcome the problem of, the stacking. You might be better off building something where you have some super substantial shelves that you can pull out, but then you're going to be needing to hold 300 pounds on one, rollout. So you could pull them out and do any kind of service to it. And we don't know if there's going to be service involved or not. We haven't run one of these things long enough, or we haven't run. We haven't even run it at all. So we don't know what we're, going to be getting into with these. But yeah, it seems sturdy, and you can lean on the back. All the build quality, the welds, everything looks pretty solid.
It's compact, but stuff wasn't so compact that it was hard to get to and put together. Even though the stuff on the front was open, you could get to it.
Yeah,
really easily. So yeah, it's a good design.
Yeah, we did the. I think we mentioned it 2 or 3 times. The pulling everything off the front like we did to put the cells in. It's kind of optional. I just didn't want to drop the cells in, by the terminals, holding the terminal posts and dropping them in there, because that's a lot of weight on the terminals. So yeah, we pulled it back so we can lay them in a little bit easier. Don't have to do that maybe. If your cells are kind of swollen, or there's a problem with them, you may have to pull it apart to get them in. But our cells are pretty flat, so we didn't have any kind of problem with it. They're not compression. There's no compressing. It's not like they're squeezing them, but it's fixing them.
Yep.
Against the movement. Yeah, bus bars, they supply those nice flexible bus bars. That's the way to go. If you don't have that kind of cell, you can actually buy those flexible bus bars, aftermarket, different places. But yeah, we're going to see. This is going to be fun. We're going to test it. We're going to really go through it and see what it's all about. But as far as it goes, that's kind of the weird thing. It's it's all about the cells, and this is just a box.
Yep.
This is a box with a BMS, and if you have a JK BMS, which we got some coming because we have some other builds we're going to put them in, a box is a box.
Box is a box, and it works.
Yeah, we're happy.
So it's a good one. And like I said, we'll probably end up doing a video on pre-builds versus DIY, pros and cons of that. So leave a comment if you want to see that video, or if you have any recommendations for other videos. So I think that's it.
Yeah.
Like, share, subscribe to the video, do all that good stuff. You know what to do. Join our Patreon, subscribe star, buy me a coffee if you want to support us so we can keep doing videos like this. Thanks so much for watching, and we will see you next time.